Okay. 5.3, inequalities in one triangle. So, first we have to remember what these inequalities are. Comparison properties. So see, hello.
Go make sure they're okay.
I think they're okay. They'll be fine. A is less than B. A is equal to B. A is greater than B. So if you forget what those are, the less than looks like an L for left, right? Less than, okay? And then greater than is not that. So if you go back a bit, we have the exterior angle theorem that said that angle 1 was equal to 2 and 3 added up. Remember that? So if angle 1 equals these two added up, then it must be bigger than they are separately, right? So if this is like 100, and this is, what did I just say, 120, and this is 80, then is it 100 bigger than 20? Is it 100 bigger than 80? Do you see what I'm saying? If it's equal to those two added up, it has to be bigger than those two separately. Does that make sense? So that's what this says. Exterior angle inequality, the measure of an exterior angle, 1 here, is greater than the measure of either of its remote interior angles, the ones that are not attached to it, right? So not this one. So measure angle 1 greater than measure of angle 2, and measure of angle 1 greater than measure of angle 3. Is everybody okay with that? All right. I think this is new for you. If one side of a triangle is longer than another side, then the angle opposite that side has a greater measure than the angle opposite the shorter side. What that means is, if you look up here, if I open my hands this far, okay, let's say this is 20-degree angle, right? Let's say this is like 4 inches long, okay? If I open to an 80-degree angle, did this get longer or shorter? Got longer, right? If this is 20 degrees and like 4 inches long, and this is 80 degrees and like 7 inches long, I don't know, it got bigger, right? So the bigger the angle, the longer the side. The smaller the angle, the shorter the side. Does that make sense? So that's what this is saying, okay? It says, if you look here, side AB is the longest side, so it has to be across from the longest angle. Do you see that? Right? So if AB is bigger than AC is bigger than BC, it's going in order from greatest to smallest, right? Then the measure of angle C, the one across from that, has to be bigger than the one across from the medium side, has to be bigger than the one across from the smallest side. Do you guys see what that says now? Okay. So I don't know what the angles are, but I know that C is the biggest one because it's across from the biggest side. Is that all right? All right. And then backwards. This time I know my angles, but I don't know my sides. So the biggest angle here is the angle C, and then angle B, and then angle A. So what side is across from angle C? AB, and then AC, and then BC. It's the same thing but backwards. Do you guys get that? Okay. It's weird? Okay. It's easy weird, right? All right, use the exterior angle theorem to list all the angles, all of them, that satisfy the stated condition. They said measures less than angle 4. So here's angle 4, right? It's on the exterior of this triangle here. What's angle 4 bigger than? Let's say it that way. What are my remote interior angles? 1 and 2, right? So if 4 is bigger than 1 and 2, then 1 and 2 have to be less than 4. If you go back to our angle theorem, exterior angle theorem that we had just 2 slides ago, I think, 4 is bigger than 1 and 2, so 1 and 2 have to be less than 4. Does that make sense? Okay. Measures greater than angle 2. Well, we already know one of them. What's greater than angle 2? Angle 4. It's backwards of what we just said, isn't it? Right? So here's what I want you to look at as well. If you look at this triangle, see that one? Right? If angle 2 is right here, but I'm looking on this big triangle, isn't 9 bigger than whatever 2 and 7 are together and 1? Do you guys see that? So 9 is also bigger than just 2 by itself, because if 9 is bigger than 2 and 7 together, then it's got to be bigger than just the 2. Does that make sense? Angle 9. And what's 4 vertical with? 6. So it's not just that exterior angle inequality theorem. You have to go back to like vertical angles and stuff too. Did you guys follow that? Okay. List the angles and sides in order from smallest to largest. They went backwards from the examples I gave you. They said smallest to largest. What did they give me here? Angles or sides? Angles. So what's the smallest angle? H. And then? J. Okay. Everybody can do that. Nobody's going to get that wrong, right? So now the smallest angle was H. So what's the smallest side? JK, the one across from it, right? What's the medium one? HK, the one across from the medium, the middle angle, right? And then HJ. The reason that I have line segments over these is because I'm listing them as like comma, comma, comma. When we had them in the theorem, I had like less than and greater than and stuff, so that's the difference, okay? On 19, did they start us with sides or angles? Angles. What's angle C?
46.
I'm saying what is angle C? We have to find it.
It'd be 90 minus 46.
Yes. 44, right? If you take 180 minus 90 minus 46, you get 44. So now we can put them in order, right? What's our smallest angle? C, and then D, and then E. Very good. That's the easy part, right? What side is across from angle C? DE. What side is across from angle D? CE. And then? CD. Very good. Did I lose anybody on this front page? Anybody confused at all? Okay. Back page. I don't know angles or sides. So what am I going to do? Find X. How do we find X? This plus this equals 180. X minus 1 plus 2x plus 3 plus x plus 6 equals 180. You guys take your time and solve for X. X is 43. Everybody take your time and get there. I'll wait for you. If you don't get 43, tell me. I'll help you. Anybody struggling with the 43 part? Okay. So we need to find each of those angles then. So what's angle P going to be? 42. What about M? 89. Q? 49. Very good. So smallest to largest. Where am I going to start? P. And then? Q. And then? M. What's across from P? MQ. Line segment MQ. Line segment MP. And then what? PQ. The only one I haven't said yet, right? It's okay.
Yeah, you skipped one, and I kind of threw around.
I skipped one.
Well, you did the Q bar stuff. Yeah.
Oh, I just said it. Yeah, I got it. I gotcha. Okay. Use the figure to determine which angle has the greatest measure. So here's where you really have to pay attention. Sometimes they say smallest to largest. Sometimes they say larger or smaller. Sometimes they say find the greatest. Sometimes they say find the least, right? So just like really watch for that, okay? So 3, 11, and 12. 3's here, 11, and 12. Which one's the biggest? 3. Because it's on the exterior, and those two are remote interiors. That's that exterior angle inequality theorem, okay? 3, 9, and 14... If you look here, still 3, right? 3's bigger than 9, and 3's bigger than 11 and 14 together, so it has to be bigger than 14 by itself. Did I lose anybody there? Okay. All right, use the figure to determine the relationship between the length of the given sides. They want you to fill in this blank with like less than or greater than or equal to or something like that, okay? So RP and MP. If you look, RP and MP are in this triangle here, right? RP is across from what degree? 70. MP is across from, I don't know, right? How could I figure that out? What do those three angles make?
180.
A line, 180, right? So take 180 minus 85 minus 60,
35.
and we get 35.
I'm good.
So MP is across from the 35 degree side angle, excuse me. So what would our symbol be?
RP's greater.
Greater than, very good. So I don't want you to think RP is 70, it's just across from 70. Do you guys get what I'm saying? Okay. So RQ and PQ is this triangle. RQ is across from 30. PQ is across from 85. Less than. Very good. Anybody confused at all? Okay.